Welcome to saitechinfo, dear UPSC, TNPSC, neet and JEE aspirants and school and college students.
The induced EMF can be obtained based on this equation, that is Faraday's law of electromagnetic induction. According to Faraday's electromagnetic induction, we already discussed that the induced EMF is equal to the rate of change of magnetic flux, and the Lenz correction is minus, and including the we know already that is a phi is equal to BA cos theta, so we can include that one also. Therefore, minus d by dt into n, that is the total number of turns of coil, B magnetic field, A area enveloped by the coil or enclosed by the coil, theta, that is cos of theta, angle orientation. In terms of angle, that is we have to say in orientation of the magnetic, the coil. So by change, because this EMF depends on the number of turns of coil, assuming that it is constant means then it depends on B magnetic field. So by changing the magnetic field, you can get the inducing EMF. By changing the area, you can get the induced EMF. By changing the orientation of the coil, we can get the EMF. Are you able to follow this? So among this, which will be very easy? One is by changing the magnetic field, okay, but it would be difficult also by changing frequently the magnetic field. And area, so you have to frequently change the area enclosed by the coil. That is also difficult. So the best thing is changing the orientation. So by rotating the the coil, that is possible. Okay, so the simplest thing is rotation, and that is why we make use of this orientation, change of orientation. Are you able to follow, to get the induced EMF? Okay. In the previous session, we were discussing about the production, that is method of producing induced EMF. Based on the equation, that is induced EMF E is equal to minus d by dt of NBA cos theta, where we can maintain the number of turns as constant and we can change the magnetic field, thereby you can get the electromagnetic induction. You can change the area, thereby you can get the EMF, induced EMF, and you can change the orientation. So the best possibility is by changing the orientation of the coil. EMF induced by changing the orientation of the coil. Look at this picture. Here in this diagram, you have got north and the south poles of the magnet. You know very well the magnetic field lines will be traveling from north to south. Now you have kept the that is a PQRS, that is the first diagram. Okay, are you able to see the the conductor, that is coil PQRS, that is vertical like this. So it blocks the the magnetic field. Are you able to follow? Right. And then now clockwise it rotates. Listen to me, clockwise it rotates. So when it is clockwise, it is rotated. If it is rotated like this, now almost that is it is not blocking the magnetic field, right? And again, so you just check here the angle. Okay, so the angle here is 0 and it is 90 degree, that is pi by 2. Are you able to follow? And this is 180 degree. So let me consider this as a coil. Okay, now it is vertical, right? And the second position, third position, fourth position, fifth position. Are you able to follow? So likewise it is rotating. So in the first case it is 0 degree, second case pi by 2, the theta is equal to pi by 2, third pi radian, fourth 1.5 pi radian, and here you are able to get 2 pi radian. So likewise the theta is getting changed. So PQRS is the rectangular coil, and as I already explained, N is the number of turns of coil, area N enveloped or that is enclosed by the coil, and B, that is the uniform magnetic field. So the coil is rotated with an angular velocity, certain velocity. What do you mean by angular velocity? That is because we already discussed how fast the magnetic flux is disturbed. Based on that you are able to get the EMF, that is rate of change of flux. Do you understand this? So by changing the rotation, so the change of rotation, that is the orientation, thereby you are changing the magnetic flux. Got it? So when you change that, you are able to get the EMF. Is it not? Right. So how fast it is rotated? Angular velocity, that is theta by t. Do you understand? Because omega is nothing but theta by t. Right. So it is rotated clockwise direction about an axis perpendicular to the direction of magnetic field. So this is the magnetic field. It is perpendicular to the magnetic field. Right. So initial position is the vertical angle 90 degree. So when it is 90 degree, then B is equal to 0, because we know cos 90 is equal to 0. So there is no magnetic field. But when it is 180 degree, okay, there is magnetic field. So after some time the coil rotates, is it not? So we know very well that is omega is equal to theta by t, or theta is equal to omega t, is it not? So phi here, NBA cos theta, and the induced EMF is given by E is equal to d phi by dt, that is equal to minus NBA into d by dt into, instead of theta I introduced omega t, because we already know omega is equal to theta by t. So theta is equal to omega t. So I have just substituted the theta by omega t. And why I kept NBA outside the differentiation? Because these are constant. So we are maintain these as constant. We are going to disturb only the orientation of the coil, okay, the theta of the coil, and that is why we have put under a differentiation. Okay, right. So cos omega t means we have got already the formula, that is sin omega t, omega sin omega t on differentiation. So you are able to get E is equal to NBA omega sin omega t. Are you able to follow? Then the maximum value of the induced EMF is E naught is equal to NABW. So we are able to get the induced EMF, and that can be represented as what? That is E is equal to E naught sin omega t, because here it indicates the maximum value, that is this E naught. Therefore, E induced EMF at any instant can be given as E naught sin omega t. Got it? Now, the induced EMF, that is E, varies sinusoidally with the time and the frequency. Are you able to follow? Sinusoidally means that is as a sine wave, because it is sin omega t. Okay, so this can be represented as in terms of frequency also. So in that case, nu cycles per second, nu frequency. So nu is nothing but omega divided by 2 pi, because omega is equal to 2 pi nu. So you can replace nu as omega by 2 pi. When omega t, that is theta, is equal to 0, the plane of the coil is perpendicular to the field. Now look at this, assuming that this is the coil. Okay, so we have got, this is the coil, I kept like this. Now let me say P, Q, R, S. Okay, now when it is kept vertically, are you able to follow? So when it is kept vertically, that is plane of the coil is perpendicular to the magnetic field. Okay, hence E is equal to 0 because theta is equal to 90, is it not? So E is equal to 0. When omega t is equal to pi by 2, that is 90 degree, okay, then it becomes what? That is, the plane of the coil is parallel to the magnetic field, or you will see this parallel to the magnetic field. In that case, E is equal to the maximum EMF, that is E naught. And when omega t is equal to pi, okay, then the plane of the coil is again a right angle to B, then E is equal to 0. So likewise keeps rotating, and when omega t is equal to 1.5 pi, then we are able to get the plane as, that is, parallel to the magnetic field, and therefore there will be a induced EMF but in the opposite direction. So E is equal to minus E naught, and again when it is a 2 pi, it is perpendicular to the magnetic field, so cos 90 is equal to 0. So E is equal to 0. So likewise you should be able to get what? Alternate ups and downs in the EMF peak. Okay, right. Now so far we have discussed how the induced EMF can be obtained by changing the orientation of the coil. So you have to remember this diagram. Remember that you have got only one set of coil, but in order to indicate the position, different positions of the angular positions of the PQRS coil, we have made it as a 4 coil. Okay, it doesn't mean that we have kept a 4 coil, just we wanted to indicate the position of the coil. First vertical, second horizontal, third vertical, again horizontal, fourth vertical. So based on that we are able to interpret the EMF and with respect to the angle. Okay.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.